Hello, in this C programming video, we're going to be going over finite state machines. They are crucial for modeling system behavior, especially for protocols, parsers, and game logic. They provide a clear, deterministic way to describe a system's response to inputs. A classic example of a finite state machine is a turnstile. It perfectly illustrates discrete states and specific transitions triggered by events. In this video, we're going to be creating a C program that simulates a simple turnstile with two states, being locked and unlocked, as well as two events, inserting a coin and pushing the arm. So if you find these types of videos informative, feel free to give this video a like and comment with any questions or thoughts. In addition, please subscribe to the channel to get more videos like this. It proves that you like the sort of content, and I'm happy to keep providing. So again, in this file here, we're going to be creating a turnstile finite state machine. This program is going to model a simple turnstile using a finite state machine approach. The system changes its behavior based on its current state and the input event it receives. So our two states are going to be locked and unlocked. And the two events are coin inserted and push arm. The logic, there's three main points here. Point one, if the state is locked and the event is coin inserted, the state is going to transition into an unlocked state. So we're going to allow entry at that point. If the state is unlocked and the arm is pushed, there's going to be a transition to a locked state. So the entry is completed. Any other combination is going to result in no state change, and then there will be some sort of action that the user will see. So a very good way of representing this before you start coding is a finite state machine. A finite state machine transition diagram. So it's real simple to do. There's plenty of different ways you'll see it, but the point is that you and your colleagues can understand what's going on. So I just use a simple circle for being a state, and then a directed line being the event. Looking at our locked state here, I'm keeping in mind the two possible events that happen. One is coin inserted, and the other is the arm is pushed. If the state machine is locked and the coin inserted event happens, we transition to an unlocked state. Otherwise, if it's a push arm event, nothing happens, so we just circle back to locked. Even though it doesn't do anything, I'm directly saying that here. So that's good practice. Additionally, looking at the unlocked state, if we have a coin inserted event, nothing happens, so we circle back to the unlocked state. But if the push arm event happens, we transition back to a locked state. So before you even get your IDE out and start programming, get a piece of paper and draw a state transition diagram. This is for programming. This is for a basic computer engineering class. It's for everything. So even if you're taking a test or something, I highly recommend you do this. Show your professor that you understand the concept. But now that we have this understood, we'll refer to this, but let's start programming now. So first, let's include our libraries. We really only need our standard input-output and standard library, so we're going to do that. We're going to include those. So now that we have our libraries included, we're going to start with our definitions. So first, we're going to start off with our enumeration for the possible states. And by far the best way to do this is using enums. So we're going to do type def enum, and then inside here we're going to, in all caps, we're going to put our possible states. So they are locked, and unlocked. And then we're going to call this enum just state. Next is our events. And then same thing, we're going to use an enum here. So type def enum. And then our two states are coin inserted and push arm. So we're going to call this enum event. The last thing we need is our global variable to track the current state of the system. So we're going to do a state variable called current state. So again, this is a variable to track state of machine. Now that we have our definitions taken care of, we can move on to our second step, which is the core finite state machine logic or transition function. Your professor or teacher will refer to either of these two things, so finite state machine logic or transition function. And we do this with a function. So nothing's going to be returned here, so we're going to use the void that return type. But we're going to call this function handle event, and that's what you'll usually see it called in your class. So we also pass in the parameter, which is the event. The event makes the thing happen, and we're just going to call it event, lowercase event. First, before we even start with the logic, we're going to print the action taken. So event received, and then our first format specifier, which is the event, and then our second format specifier, which is the current state. And then we have to pass in what those are. So since there's only two states and two events, we can use a ternary operator. So event, if the event is coin inserted, we're going to print out coin inserted. But otherwise, we're going to print arm pushed. And then we need to print out our state. So we do current state. If it's locked, we're going to print out locked. But otherwise, we're going to print out unlocked. So now that we're done with that, we're going to use the core logic. And the best way to do this is a nested switch case structure, because we have specific events and we have specific states that we get to work with. So we're going to do switch, and then first we're going to do state. That's going to be the outside switch. And then we have two cases with the state. Either it's locked, so that's our first case, or it's unlocked. And again, at the end of each switch statement, we have to do use the break keyword. And then within each state case, we need to do an inner switch statement for the event. So switch event, and then we have two options. We have the coin inserted case, or we have our push arm case. And then we can just copy and paste this for our unlocked state as well. So now that we have our switch case or nested switch structure done, let's actually do the logic. So for our first combination is a locked state with a coin inserted event. If that's the case, again, referring to our state transition diagram here, we're going to switch from locked to unlocked. So we're going to first change the state. and then we are going to inform the user with printf. And then we break. Our next combination is we're with a locked state and the arm is pushed. So looking here, nothing happens. We just go back to a locked state. So we want to inform the user of that. So the arm is pushed, but no coin is paid. So we can associate that with some sort of alarm or buzzer of some sort. And then we break. Our third state event combination is an unlocked state when the coin is inserted. And again, referring to this, when the coin is inserted with an unlocked state, nothing happens. So we can notify the user that there's not exactly an error, but nothing happens, and then we break. Finally, with an unlocked state and a push arm event, as we can see here, we transition to a locked state. So we can change the current state to be locked, and then we can notify the user that there's a state transition, and then we break. So once this is done, now we have our actual logic, so we can now inform the user of the new state. So we're going to use printf again. We're going to say what the new state is, and then we're going to do the same exact thing as above. And now we're done with our handle event function. So moving on now, we have our function. So now we can do our main simulation, or in other words, just test our function. So we're going to do int main, and we're going to first start our simulation here for decorative purposes. And we're going to start our system in the initial secure state. So we're going to do current state equals locked. And the first thing we're going to do here is, well, we're also going to print it. We're just going to say that it's locked as well. So now that we're set up, our first test is going to be a normal successful passage. So inserting the coin and pushing arm to go through. So again, we do that. We start at our locked state. We insert the coin, so we transition to an unlocked state, and then we push the arm to go through. So once we're through, it's locked for the next person. So we're gonna do that by doing handle event, and then first, what are two options? Well, coin inserted. So here we are inserting the coin, and then we are pushing the arm to go through. So that is our first test. Now let's do our second scenario here, which is trying to push without paying. So simply we're going to, if it's locked at this point. So we're going to just try to push the arm. But as we can see here, if it's locked and we try to push the arm, nothing happens. So the expected behavior is a locked to locked state change, i.e. nothing. Now, that was our second test again. Trying to go through without paying. And now finally our third test is going to be paying twice. So we're going to handle the event inserting the coin, and then we're going to try to insert a coin again. So again, inserting a coin from a locked state is going to change it to being unlocked, but trying to insert the coin again is not going to change anything. But if we pay here, we would expect it to give a change or something. And then we can handle the event to push the arm. So let me, before we compile this, let me kind of give some headers here. Scenario 1, scenario 2, and then scenario 3. And then we can say that once we're done with our tests, we can finish off the simulation. Again, just decorative, but to show off what the code does. And then we can return 0. So again, this code test, the main point of this is to test our handle event, and then the handle event uses our definitions. So let us create a new terminal here. We can compile our code. Again, we don't need any extra arguments here, just calling it turnstile. And then let's execute it. So we can see here, the initial state is locked. Scenario 1 is a successful passage. So the event received is a coin inserted. The current state is locked. The action is unlocked, so it changes the state, and then the new state is unlocked. Then an event is received being arm pushed when the current state is unlocked. So that will the action will be it will lock it again. So there's a state transition from unlocked to locked. So the new state is locked. Scenario 2 is an unauthorized entry attempt. So if the arm is pushed and the current state is locked, there's some sort of alarm or buzzer. And then scenario 3, the event received, coin inserted, current state is locked, there's a unlock state transition. So if at this point it is unlocked, so if there's another coin inserted, a change is given and the state remains unlocked. Then if the arm is pushed and the current state is unlocked, the user goes through and the action is to lock the turnstile again. So if you found this tutorial helpful, please give it a like. Otherwise, subscribe for more videos like this. Comment with any questions or thoughts. Thank you for your time and watching this video, and have a great day.